So throughout elementary school, money is often used to describe, as an example for a number of different operations, because it takes, especially as we get into decimals, it takes us into the tenths and the hundredths place with dimes and pennies. And so it's often a good example to start. It's no different in division as well. So let's take a look at how kids might look at division of 2,674 by 3. So let's see how that would happen. So first of all, let's look at some of the denominations that we might use in this situation. So we would have a $1,000 bill, right? Or in fact, we have $2,000 bills in this. We may also need $100 bills. In fact, we have 6 of those. We may also use $10 bills. In fact, we have 7 of those. And we have $1 bills. In fact, we have 4 of those. So if we were asked to divide that amount of money into 3 groups, it doesn't look natural, like we can easily do that if this is the way that our denominations are. So splitting 2 $1,000 bills amongst 3 people is kind of challenging. So we're going to have a little bit of a bank to change things with. Now, also, it's possible that we won't be able to divide that evenly, so we might need our coins. And what kind of coins do we have? We have 25-cent coins, we have 10-cent coins, we have 5-cent coins, and we have 1-cent coins. Okay, so let's take a look at the situation where we might have to split up these denominations into 3 different people. So I'm going to take this, copy that, and give myself a little bit more room here. All right, so if we are trying to split this between 3 people, so let me see if we have person 1, person 1, person 2, person 3. Okay. It doesn't look like we will be able to take the $2,000 bills and just easily split them between the 3 people. Instead, what we will probably do is take those $1,000 bills to the bank and make them into 20, right, $100 bills. So we're going to unbundle the two $1,000 bills, and we're going to trade them for 20 $100 bills. Now, if we have 26 $100 bills now, okay, how can we split those up between the 3 different people? Well, 26 isn't really something we can split between 3 people, but 24 is. We know on the side here that 24 is 3 groups of 8. So we know that each person could get 8 $100 bills. Oh. Okay, so each person is going to get 8 $100 bills. Okay. All right, now that will have split up our $2,600 bills into 24 $100 bills, and which we split up, and 2 more $100 bills, which we really can't split between 3 people. So instead, we're going to say, all right, I'm going to go to the bank and I'm going to trade those 2 $100 bills into 20 $10 bills. Okay, so now we have 27 $10 bills to split up. So let's see how we could do that. Could we split up the 27 $10 bills between 3 people? Sure. Be 9 $10 bills each. Okay, so 9 $10 bills each. So that we were able to split between all of our 3 groups. Now let's come to the 4. for $1 bills. So we can do 3 $1 bills, one $1 bill each. Whoops, one $1 bill each. Fighting with technology here. $1 bill. Okay, there we go. All right. So we can certainly do that. And then we would have $1 bill left. Now, there's nothing we can do with this. We can't really rip the $1 bill between the 3 people. So either we have $1 remaining as a remainder, or we may be able to get into coins. Now, notice that if we were to follow our pattern of 1,000, 100, 10, 1, then the next coins that we may want to use are 10 cents and 1 cent, right? Because then we would have a tenth of a dollar and a hundredth of a dollar. So, but some kids will be tempted to use quarters and nickels as well. So let's see what would happen if we used the quarters and the nickels, and then we'll go back and redo it in a way that only uses the multiples of 10. So let's say that we're going to follow the same kind of strategy. So I'm going to switch to green. And actually, let me switch to pink. And use the quarters. So instead of having $1, I'm going to trade $1 into 4 quarters. All right. So then each person will get 1 quarter each. 1 quarter. Okay, 1 quarter. Then, so we would have split the 3 quarters between and be left with 1 quarter. Well, what happens if I split the 1 quarter into nickels? That's not going to help. Into dimes, pardon me. That's not going to help because I'll have 2 dimes and 1 nickel, and I won't be able to split that evenly without between the 3 people. So I could trade it for 5 nickels. And then what would I be able to do? I'd be able to split the 3 of them. So I'd have 1 nickel per person. Okay, so that's been split, and I'd have 2 nickels left. Now that I could certainly split into 10 pennies, and then each of my people is going to get 3 pennies. So that will have accounted for 9, and I'd have 1 penny remaining. Okay, 1 penny remaining. All right. So how much will each person have gotten? Let's see. We would have gotten 800, 90, $1, and 25 cents and 5 cents. That's 30 cents. And another 3 pennies, 33 cents. $891.33. Okay. Now, so that's if we are using quarters and nickels. So let's go back and erase the quarters and nickels. Oh, can I not do that? Interesting. Okay. I wonder. There we go. There are lots of ways to do this. I kind of love technology. Okay. So let's get back to using coins, but right now we're not going to use quarters or nickels because those don't fit in the pattern of place value. So if we were to trade $1 bill, we would be trading into 10 cent coins, right, into 10 dimes. So let's see. So 10 could be, 9 of them could be split up. So 3 10 cent pieces in each, and 1 would be left. Okay, and again, I wouldn't be able to split the 1, so I would have to trade it in for some pennies. So it would be 10 pennies, and again, I'd be able to split 9 of them between the 3 people, 3 each, and 1 would be left. So let's see what we would get if we used this strategy. So we'd still have $891, and then 3 tens and 3 10 cents and 3 pennies. Unfortunately, we are getting to the same value. So money can be used to show division and to show division with decimals.